All right, welcome to lecture 28. This lecture is going to have three parts. So there's a part A, B, and C. So the next two, there's some math in it, but this very first one, no math at all. Yay, no math. What we're going to do instead is we're going to look at a few more terms that have to do with making up solutions. So you might remember in the last videos, like lecture 27, I guess, we're talking about, well, one way you make up a solution, you get out a cup of water and you throw some solid into it. And then you got yourself a solution. So what we're going to focus in on in the beginning is, well, you know when you dissolve a solid, whether it's sugar or salt or whatever, there's always just so much you can dissolve. And if you keep adding more sugar or adding more water or adding more salt, I should say, it quits dissolving. All right. So there's always a limit on how much stuff you can dissolve in water. And we're going to go through how that works and why it works in this video. All right, let's go and get started. So this idea that you can only dissolve so much stuff, that has a name. That's called the solubility of something. So let's define that a little better. Solubility is the amount of a solid that can be dissolved in water. It's the amount of stuff you can dissolve in water. And when I say amount, typically what I mean is how many grams of stuff can you dissolve in water? Now, it's not the same for everything, so what does it depend on? Well, one thing that it depends on is this idea that we say like dissolves like. Like dissolves like. So what do I mean by that? Well, what I mean is that if you have something that is polar, or it could actually even be ionic. You might remember polar means that you're a molecule that has charges inside of you. And ionic, yeah, that's also something that contains charges. So we could say polar or ionic substances dissolve well in polar liquids. All right. On the other hand, I could say if you're nonpolar things, we know what nonpolar is, right? Somebody without charges. Nonpolar substances dissolve well in nonpolar liquids. All right, so let me give you a few examples. So something that's polar or ionic, anything that's a polar compound or ionic compound, it's going to dissolve better in polar liquids. So you can see a list here on the left, right? Some polar liquids with the things like water or acetone or alcohol. They're all polar. So polar things dissolve well in them. There's plenty of nonpolar molecules in the world too. Nonpolar things dissolve better in nonpolar liquids, like mostly those would be like oils. So like hexane and toluene, those are kinds of oils, or ether, that's another nonpolar liquid. All right, so you dissolve better when you're around things that are similar to you. All right, what else matters? All right, another thing that matters, and we should make this number 2. I'm going to move this down a little bit, is that this one only applies for gases, I should say. For gases, because you can dissolve a gas in water too, like carbon dioxide dissolves in water. That's what you get in a soda. It's got carbon dioxide in it. So for a gas, and this should be, maybe I should say for a gas only, gases dissolve better at higher pressures. So if the pressure is higher, more of a gas will dissolve in water. And for our last one, for gas only, gases dissolve better at higher pressures, I guess. And then our last factor, so polar guys, like dissolves and like, and so on. For gases, the pressure also matters. And now for the last one, this one really only applies for solids. For solids dissolve better at higher temperatures. So if the water you're using is warmer, you're going to be able to dissolve more stuff in it than if the water is colder or cooler. All right, let me show you a little graph of this, okay? So for solids, solids dissolve better at higher temperatures, in warmer water, basically. All right, let's flip over and look at a little graph of this idea. So on this graph, you can see all kinds of different solids that we're thinking of. They're all like little lines there on the graph. And they've graphed the solubility. How much stuff can you dissolve and the temperature of the water. So this is your temperature down here. And then on the vertical axis, this is how much of some solid can dissolve. It's grams that you can dissolve per 100 grams of water. So, you know, it's not always exactly the same relationship, but generally speaking, if we look at something like KCl, when you use warmer water, you can dissolve more than if you use cooler water. So we have like 80-degree water, you can dissolve maybe 50 grams of KCl. If the water is only, I don't know, 30 degrees, you can only dissolve maybe 35 grams. So sometimes the relationship is a little more like, I don't know, dramatic, and sometimes it's not quite as dramatic. But pretty much for everything, if you use warmer water, you can dissolve more than if you use colder water. All right, so this idea of how much you can dissolve, that's called the solubility of something. All right, now there's three other terms I want to mention here, and they all have to do with, well, what happens when you really make up a solution, all right? So let me flip over to those in a second. We'll look at three more ideas, three more terms I want you to be familiar with. All right, so these terms all have to do with like, what if you actually make a solution? Like you get out some solid, you get out some salt, and you dissolve it in water, okay? So when you make up a solution, really you can make up three kinds of solutions. Like this is like something you actually do. So one kind of solution I can make is called a saturated solution. A saturated solution, what does that mean? It means it's a solution that contains the maximum amount of a solid that can be dissolved. So you've dissolved the most you could. So you've dissolved the most sugar or salt or whatever that you can be. Now we'll know how much you can dissolve because of this graph. So let's say we're looking at like room temperature water. And I don't know, let's say we're talking about, let's do KCl. At 30 degrees, the most KCl you can dissolve, you should be able to dissolve about 35 grams of it in 100 grams of water. So if you actually went out and dissolved 35 grams of KCl in that water that's 30 degrees, you made a saturated solution. Now, if you don't dissolve the most you could, that's called being an unsaturated solution. So in an unsaturated solution, you have dissolved less than the maximum amount. So again, if we talk about 30-degree water and KCl, the most you can dissolve is 35 grams. If you dissolve less than that, you have an unsaturated solution. So another way of saying that is you could dissolve more. You could dissolve more if you wanted to. All right, you could dissolve more. All right, one way. All right, so if you dissolve the most you can, that's called saturated. If you dissolve less than you can, that's called unsaturated. Now, the last one is actually the most confusing possibility. All right, I'm going to read it to you, and then I'm going to show you a little demonstration about this. So the last kind of solution you can create is called a supersaturated solution. What the heck is that? A supersaturated solution is one that contains more than the maximum amount. You dissolved more than you could, then you should be able to. Well, how do you dissolve more than you're supposed to be able to? You've dissolved more than you should be able to. A solution that temporarily contains more than the maximum amount of solid dissolved in the water. Well, how does that happen? Well, let me go back to the graph. You dissolved more than you should be able to. Well, the way you do this is, first off, you get out some water and you heat it up, okay? So let's use KCl again as an example. So if I was to warm up water and I was to get it up to 80 degrees, When it's hot, the water, I could dissolve about 50 grams of KCl. I could dissolve 50 grams of KCl in hot water at 80 degrees. Now, to make a supersaturated solution, you go ahead and do it. You heat up the water, you dissolve a bunch of something in the water, and then you let it cool. Now, as you let it cool, the water, when it cools back down, it should hold less. When this water cools back down to, again, about 30 degrees, which is about room temperature, or could even be like 20 degrees, the water should only be able to hold 35 grams of KCl at 35 degrees. But you know what will happen? All of it will stay dissolved for a while. Now, it may not stay dissolved forever. That extra weight that it dissolved when the water was warm, eventually it's not going to want to stay dissolved. So it'll eventually crystallize, all right? So let me show you an example of that. I'm going to do a little demonstration and then we'll see if this makes sense, okay? So supersaturated, you got more in the water than should be there. How does that happen? Well, you dissolve a bunch when the water's hot, and the stuff will stay dissolved, at least for a little while, when it cools back down. All right, let's look at a demonstration of this. Okay, let me show you a little demonstration I did of these ideas: saturated, unsaturated, supersaturated. So the first part I did is I just got a flask out of water, and it just has water in it. And then into it, since it's just water, this is basically unsaturated. If something is unsaturated, you can dissolve more of it. So I added, this is actually a compound called sodium acetate, all right? So I added a little bit of sodium acetate into the water, and since it's unsaturated, I could dissolve it. It dissolved. All right, so that's water. Now, this is another flask where I heated it up and I cooled it down. Now, you notice again, it doesn't look like anything's in there, but I actually have a supersaturated solution. A bunch of sodium acetate has already been dissolved in the water. So when I add a little seed crystal, all of a sudden, all of that sodium acetate crystallizes out. So this is called, again, being a supersaturated solution. More sodium acetate was dissolved than should have been, so I gave it a little nudge. I added a little seed crystal, and you could see it all crystallized. The entire flask turned into a solid. Now let me show you. I did it again, and actually this time, I just moved it around, and just by moving it, that made it start to crystallize, even without adding a seed crystal. You can see the crystals growing in there. So supersaturated solutions temporarily have more stuff dissolved than should be, and then when they get a little bump or you add a little seed crystal, all that extra solid will turn into, all that extra stuff that you dissolve will turn into solid. It'll form a crystal or precipitate, you could say. All right, so with that, hopefully that makes sense. Let's go ahead and move on to one more or a couple more ideas. Oh, maybe we'll do a practice question, actually. All right, let's do a couple practice questions, see if this is making sense. A supersaturated solution contains less than the maximum amount of solute at that temperature, contains the maximum amount of solute at that temperature, contains more dissolved solute than the solubility limit at that temperature. Which one of those sounds like the best answer? Oh, it's C. You have more stuff dissolved than you should be able to, than the solubility limit. All right, that's called a supersaturated solution. All right, let's do one more practice question here. One more practice question. All right, our second practice question on this topic. If you dissolve 25 grams of salt, NaCl, and 100 grams of water at 20 degrees, you will have made a blank solution. Now, I tell you an important fact underneath that. The solubility of NaCl at 20 degrees is 45 grams per 100 grams of water. What's the right answer? A, B, or C? Oh, it should be A. It should be unsaturated. All right, so what did this mean if you got a little mixed up? You went out and dissolved 25 grams of salt in 100 grams of water. Now, they also tell me we're at 20 degrees. Why does that matter? Because the amount you can dissolve changes with the temperature. So the next thing they tell me is, hey man, you could actually dissolve 45 grams of salt. So we have dissolved less than we could, less than we should be able to. That's called unsaturated. All right, with that, let's move on. Now, there's actually two more terms I want to mention to you. Let me flip over and we're going to put them up real quick. Let's get to our last two terms. All right, our last two terms. So so far we've kind of been always talking about in this video pretty much dissolving a solid in water. That's kind of been the scenario. Now, when we make solutions, as I've talked about earlier, it's not always a solid in water, right? You could mix, for example, two liquids together. And there's some words that go along with that, all right? So if you mix two liquids together, liquids can be miscible. Oh, I want to make sure I spell this right. Miscible. Or they can be immiscible. So miscible just means that we're talking about two liquids that mix. And immiscible is two liquids that do not mix. Now, why are you going to mix or why aren't you going to mix? Has to do with similar to what we talked about earlier. Like dissolves like mixes with like. So well, miscible things, that's going to happen if you have two polar liquids, or it could be two non-polar liquids. Like mixes with like. Why don't things mix? Polar and non-polar things don't mix. So like oil and water. Water is polar. Oil is non-polar. It doesn't mix. So they're immiscible. All right, so that's kind of it for the vocabulary part of this lecture 28. Oh, we got more to go though. In the next two parts, we'll be doing a little math. So if you have any questions or some of these terms don't make sense, let me know. I'll do my best to help you out. All right, let's move on to part B.